Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We are going to finish up section 2.5 here with this set of notes, and we'll kind of complete pretty much everything else that could come up with finding zeros of polynomials. You know, the one thing we really haven't discussed a whole lot yet is what happens with imaginaries or complex zeros, and that's really what we're going to look at with these. So, properties of roots and polynomial equations. Well, if a polynomial equation is of degree n, that means the equation has that many n roots. So if it's 4th degree, 4. If it's 5th degree, 5. If it's 3rd degree, 3. Quadratic, which is 2nd degree, has 2. Complex zeros occur in conjugate pairs. If a plus bi is a zero of the function, then a minus bi is a zero of the function as well. You know, if you think back to when we did complex numbers with division, we use the conjugate pair, and that's kind of leading into what we're doing here. So, this first example is where we're going to actually do a question where we're working backwards. Find a 4th degree polynomial with real coefficients that has -2, 1, and 2i as zeros. Well, what this means, again, they've told us it's 4th degree. -2, 1, 2i. Now, we did some questions like this back in the first half of chapter 2, where sometimes we would have a multiplicity involved because the degree didn't match what we gave you. Well, here, it actually does technically match 4th degree with 4 unique roots, because if it's 2i, our other zero is going to be -2i. So from here, x plus 2, because we've told you x equals -2. We've told you x equals 1, x minus 1. We've also told you x plus 2i for that one, and x minus 2i for this one. Now, we do not need you to multiply all of this out. The only thing that we are going to ask that you do multiply out, so we have real coefficients, are the x minus and x plus 2i. So, from here, x times x is x squared. There is a minus 2ix. There is a plus 2ix. Now, if you said, hey, I didn't need to actually write that out, don't worry about it. And then there is a minus 4i squared. And once again, if you would have even said, I didn't need to write this out, I could have just told you, hey, this is x squared plus 4. By all means, do that. You know, that's just letting you see where that all came from. Now, the only other thing that we will ask, it does say 4th degree polynomial, meaning an equation, so either y equals or f of x equals. So, certainly I think you did things like this last year. Although last year, I feel like in Algebra 2, we actually even have you multiply it all out. Now, as long as you leave it in factored form where all of your factors are real values, that's all the further we need you to go with this one. All right. Example 2, find all the zeros given that 1 minus 2i is a 0 for f of x equals x to the 4th minus 2x squared plus 16x minus 15. Well, we've told you that x equals 1 minus 2i. That also means x equals 1 plus 2i. Now, I'm going to go or talk through a couple of different ways of going through this. Well, if we are going to set up our factors, because it's always the opposite, so x minus 1 plus 2i and x minus 1 minus 2i. Now, we are going to go ahead and distribute these, and when we do that, it does get a little bit ugly. X times x is x squared, -x, -2ix. Then I'm going to distribute everything with the -1. So -x, +1, +2i. I'm not going to quite be able to fit everything in. There's a plus 2ix. there is a minus 2i, which you'll notice when you multiply this out, everything that is imaginary cancels. And then there is a minus 4i squared. So what we are left with is x squared minus 2x, and then I'm going to change this into a plus 4 plus 5. Now, so we know two of our zeros here. Now, from here, what we can do with this is do long division. With what we have up here. And that will allow us to find the other two. So x squared divides into x to the fourth as x squared, and then we will distribute and subtract. Be careful, 0 minus negative 2 is positive 2x squared. Negative 2 minus 5 is, whoops, that's a third. And then I'll bring down my 16x. 2x cubed divided by x squared is 2x. And then again distribute. So 2x to the third minus 4x squared. And let's see here. 10x. And then we will again subtract. We've already distributed, so that cancels. Negative 7 minus negative 4 is positive 3. 16, and that's not a square. 16x minus 10x is 6x. Last thing we will do is bring down the minus 15, and then when you divide here, positive 3. So from there, 3x squared minus 6x, and minus 15, and let's see, that's actually a negative 3. I was like, something's not going to match there. So that is a negative 3, which will change all of these. And now you kind of have some built-in checks as you go, because you'll see when you do this, these will all cancel. And that's why I was like, I knew I had a mistake somewhere in there. Now, from here, with what's left, the x squared plus 2x minus 3 will factor into x plus 3, x minus 1, and x equals negative 3 and positive 1. Now, the reason why I did not actually get out the graphing calculator on this one, this is a question where if it was on a quiz or a test, we would give you as a non-calculator part, because you were able to build a quadratic to then divide in to find the other quadratic to factor it out. Now, on that test, if you want to randomly try the factors of negative 15 until you find ones that work, you are certainly welcome to do that, but did want to, show you the reason why, we weren't just, plugging it into the graphing calculator right away. So, again, if we give you one where we give you one of the imaginaries, you can list the other one, distribute it out, divide it in, and then, like I said, because we knew it had to be 0, here's where if you get stuck, it's like, okay, what did I do wrong? Well, what I did wrong, obviously, was I did not have the negative there. Your remainder will be 0, and then it factors. So, negative 3, 1, 1 minus 2i, 1 plus 2i are your zeros there. All right, one final example. Write f of x equals x to the 5th plus x cubed plus 2x squared minus 12x plus 8 as product of linear factors, and find all of the zeros. Well, again, for this one, possible zeros, factors of 8, 1 and 8, 2 and 4. And so for one like this, here, we haven't given you anything to start. So we'll go ahead and plug back in, clear that out, x to the 5th plus x to the 3rd. Sometimes the question comes up when you are entering it into the calculator, you do not need to worry about a missing term. That'll only be when you're actually doing any mathematics to find things. All right, so we have a 0 at -2 and looks like at 1 as well. So what we can do from here, synthetic division. 1, 0, 1, again, because of the x to the 4th, I do have to put that there. 2, -12 and 8. 1, -2, -2, +4, -10, -8, 16, 4, and -8. So our remainder is 0, which is good. We have verified or found -2 is one of the zeros. Now, coming back to this one, x equals, again, 1. So I will set up another round of synthetic division with 1. And from here, our remainder is 0, so x equals 1. Now, here's where I can look at this and see, okay, x cubed minus x squared plus 4x minus 4x equals 0. I can see 1, -1, 4, -4. Those are going to allow us to group. Whoops. Let's try that again. X to the 3rd minus x squared plus 4x minus 4. And now we can group. Out of these, take out x squared. Out of these, take out 4. So the x minus 1, x squared plus 4. Well, basically what this tells us, x equals 1 again, multiplicity of 2, which, yes, you would have been able to see that. It bounces there at 1. And then for the remaining 2 solutions, x squared equals -4. When you square root it, x equals plus or minus 2i. So, -2, 1 with the multiplicity of 2, and then the plus or minus 2i does not show up on your graphing calculator. So, other than that, you can see here a couple of examples that we've now looked at with imaginary or complex zeros as well. But that completes section 2.5.